Welcome back to Outboard Motorbike. Got a bit of progress here at long last, but we've got some bits back from the machine shop. That specifically, which used to be the input shaft that came down from the power head to the bevel gear, is now the output shaft. These taper rollers, the other half of which is already in there, and that's the original input bevel gear, which all go together like this. So, one taper roller there, bit of spacer, then that, and the washer and nut, like so. Another one goes in the other end, with another nut, specially made. And that assembly, well, would have it done up probably, Malcolm. That assembly lives in this gearbox case, and takes the drive out to the sprocket for the secondary drive. There'll be spaces in here to set up the position of that and get the preload right, but that's the next step. I'll show you how. That little assembly is now assembled into the output shaft housing. Spins around okay. And the next step is to set the depth of the pinion for the correct engagement. And to do that, use this little tool that Malcolm made, which fits into the bearing bore at the back of the housing, and that diameter is the same as the Mercury pinion depth setting tool, which is 2.576 inches. And that goes in there and finds a nice home. We set the pinion depth by achieving a 25 thou gap from the outside diameter of that tool into the end of the pinion, and we can make a spacer to go behind the pinion, and that'll be in the right place and carry on from there. One thing at a time. And for further excitement today, this is our other shaft, which used to be the propeller shaft in the outboard motor. It's now been shortened and has the crankshaft spline cut on it, so that's now the input shaft. And this is our input bevel, which has got I've put a sleeve in there, pressed it in and bored it so that it's a sort of tap-in fit basically onto there, which stops it rocking when it's in the box. And the dirty big taper roller bearing there, and the dog ring pops on like that, and this little bearing lives in the other housing. So between those two bearings we've got it located. That holds it in gear. There'll be a little collar from there to hold the dog ring in place, and that's all ready to go in the gearbox. With all the spacers now ground up to the right thicknesses, that assembly is ready to put in, I think, for the final time. So that's what I'll go ahead and do with some oil, and move on from there. And that's just, in case you haven't seen it before, this little bearing that goes on the end of the input shaft to hold it straight. All ready to roll. And there it is installed. It's got 2 thou of preload on the bearings and 60 foot-pound on that nut. That nut's holding the pinion on because the pinion is trying to suck itself into mesh, so it's pretty important. And it's got 648 Loctite on it, which is the Loctite you put on when you never want it to come undone. Having got that set up, the next step is to get the backlash set up on the input bevel, and we keep moving along. And here's the other half of our gearbox, the input side. The input shaft with the bevel gear, which is now a very light press fit on there to keep it nice and straight. And the input shaft housing, which has got the taper bearing in there, and the oil seal that in to keep the oil in the gearbox. And that goes in. There we go. Like so. It's a better angle, isn't it? And to be able to adjust the backlash, we've got a shim that goes in there, which we can have of various thicknesses and surface grind to the right thickness to get the correct backlash for the bevel gear set. And then one goes on the end. When you turn this around, that goes around. It's even in the right direction. So nearly done with that. Pretty happy. And here's a little bracket that goes between the gearbox and the sandwich plate, hacked out of a bit of 50 by 50 by 6mm aluminium extrusion, which is quite nice stuff because apart from being a handy shape, it's made of, I don't know what grade of aluminium it was made of, but it's something quite decent and makes nice brackets. And there it is in place. And I think I have to say the reverse engineering department's done a reasonable job there because it fits probably within 1/4 mm, and countersunk screws because that still leaves us room for the gear lever to sit on there and run past it. I don't know whether the gear lever is going to end up there, but at least it's an option. Now here's a little something that's worked out easier than expected. That's a little 6mm laser cut steel water outlet fitting, which sits on the sandwich plate, but the water has to get, actually no, it's inlet, isn't it? Get into there at 90 degrees underneath the Harley gearbox, and it's quite tight, into a 1-inch pipe. But to make that transition round the corner, it's a sort of interesting fabrication job. But as a starting point, we've got that, which I dreamt up in bed somewhere in the middle of the night as a way of getting it started. So what I did there, I just cut straight down, straight across through half the tube, flattened it in the vise, turned the corners up, and that's the size of the outlet, so I can weld that on there and build the rest around it, which saves building a jig and a bit of fannying around. So pretty happy with that. And there's a progress report with a bit of Tash Sultana in the background. Further progress there, and a little elbow, and as you can see this edge is a bit in the wrong place and unnecessary, but plan is to get our favourite tool, the oxy torch, heat that up and knock it down. We'll just have to fill in the edge. Stand by. And here's a little water inlet pipe after we've had the oxy around that edge and hammered it down. So 2 more bits to fill in those final gaps and we're done there. And while I was about it with the oxy, I annealed that end of the tube because I wanted to roll a bead into it to stop the hose falling off later. Little fabrication tip here. So there's the last bit about to be welded in and held in place by this little magnet, because otherwise it'll just fall through the hole and disappear. And there's our finished water outlet fitting. I eventually figured out it was the water out, not the water in. A little swage on the end to stop the hose blowing off. It's made of 7 pieces of metal welded together, which obviously you wouldn't do that in production. You'd make it out of probably 4 at the most, 2 pressings and a bit of tube and the flange. But as a one-off, with no special tooling, I think that's quite a reasonable outcome. Just a quick before and after here. That's our Harley clutch assembly, which I've pressed out, so I can remove that, which leaves the basket with the ring gear attached. And I'm about to, oh, it's heavy, drill those rivets out so we can take the ring gear off and take that flange off and make it a bit more compact to go in our outboard motorbike. There you go. Ring gear's gone. The flange that it used to mount on is gone, which makes the whole thing a lot more compact. So put the clutch back together and carry on.